Hello everyone, we are going to learn today about finding the sum of a geometric series. And a geometric sequence is one where the terms have a common ratio between them. Okay, which means that if you divide term 2 by term 1, you'd get a ratio, and that would be the same ratio that would give you term 3 divided by term 2. Okay, and so what we have here is a geometric series. Okay, so if we want to find the sum of the first 13 terms, there's a nice formula we can do. I mean, what we could do is figure out, we've got term 1 here and term 2, 3, and 4. We could figure out all 13 terms and then just add them together, but that would take forever, right? So instead we're going to use this nice formula. Term 1, r to the power of n minus 1 divided by r minus 1. And what we have to do now is figure out what term 1 is. It's 3.5. And we need to figure out what r is. And r is going to equal, we can just go term 2 divided by term 1. And what do you know? That equals 5. Okay? And n, in this case, n is 13. So if we were trying to find some of the first 13 terms, then n is 13. So we can plunk some numbers in here. So term 1 is 3.5. R is 5. N is 13 minus 1 over R, which we said is 5, minus 1. Now, you're probably thinking that is going to be a very big number, and you're right. So what I'm going to do is use my calculator here so that we get a correct answer. So 3.5, and that's going to multiply all of this. So I'm going to go 5 to the power of 13 minus 1. So 3.5 is multiplied by 5 to the power of 13 and the negative 1. And I'm going to divide that whole thing by 5 minus 1, which is 4. And we get a very large number. 106 811 811 5234 5234. I'm going to put some commas in there as well. Okay, 1,068,115,234. That is a large number. So if we would add the first 13 terms, we'd get a very, very, very large number. And we could get other questions as well. We could get a question like this. So plus 1,367,187.5. Way down the sequence somewhere, this series, we're going to get a term here. I'm not sure which term it is, if it's the fourth term or the maybe the 40th term. So we're just going to call it term n, because we don't know which term that is. And we want to figure out the sum of these terms, and it's going to include some unknown terms in there, because if this is the 40th term, then we need terms 40 through 39 as well. However, we don't actually need to know what those terms are. We can use another formula like this. So Sn equals R times term n minus term 1 over r minus 1. And r is still equal to 5. Term 1 is 3.5. Term n is that number. So we can put numbers in there. So 5 times 1,367,187.5. And this is just multiplied by that. Minus term 1, which is 3.5. Divided by 5 minus 1, since r is 5. And I'm going to bring out the calculator again, because we've got some big numbers here, and my mental math right now is incapable. You know what? I could probably do it right, but I'm not going to do it right now. 5 times 1,367,187.5. It's hard enough just to say that number. Minus 3.5, and this whole thing is divided by 4. That's why I've got brackets at the beginning and end. So divided by 4, enter, and so now we've got equals 1708983.5. 8983.5. So the sum of all these terms, including the ones we don't know, is equal to 1,708,983.5. So those are two different formulas you can use. For this one, you need to know the last term in your series. For the other one, you don't know. You don't need to know it, but you do need to know how many terms you are adding. I hope that helps. I think it's helped me, so have a great day.